As a second instance of static window, let's explore the scenario in which the propagation time dominates the transmission time. A real-world scenario can be compared. That is, think about sending packets on the satellite link. The very fact that satellite links take considerably longer propagation time, the effect of transmission delay compared to the propagation delay is minimized. What is the impact on the performance of windowed protocols if TCP uses a static window as a case under consideration? Let's explore that. In this module, we shall see what is the second instance of static window transmission, and then we'll try to model it. The reference again is Quiroz and Ross. Since it is again a single communication link network scenario, so in terms of visualization, it is unchanged. The obvious change that we realize is that since the distance is too large, so the server, when it starts transmitting window worth of data, before it receives the acknowledgement for the first segment, the window is transmitted because the round trip time is dominating the transmission time. Mathematically, we can say that the time it takes to transmit W segments, each taking S divided by R time, is much less as compared to the round trip time. As I said, it is a scenario in which the propagation delay dominates the transmission time, such as satellite link. On a timeline, if we visualize the relationship between client and server communication through message flows, we'll see that when server sends the window worth of data, the complete window gets delivered and there is some stall time. Stall time is the idle time when the server is doing nothing because it has sent windows worth of data and it is expecting an acknowledgement, and the time has elapsed and no acknowledgement has reached so far. So this stall time is an additional time that we see here in the case of the static window. Again, after receiving the acknowledgement, the server sends window again, and the same procedure follows. So the overall delay that we would see here would include the round trip time, the time it takes to download the complete object, shown as O divided by R, and a third expression. The third expression comprises the left-hand side as K minus 1, where K is the number of windows that cover the object. Here in this case, the value of K is equal to 2. So we see that the inner expression, that is time it takes to transmit a single segment, and the round trip time, actually is getting reduced or subtracted because of the availability of the additional factor K. So the overall time from the third expression is time it takes to transmit a single segment, time it takes for the round trip propagation, minus the window worth of segment transmission. And this subtraction is only taking place because we have included the factor of K here.